Hello and welcome back everyone. Today we're looking at class templates. So similar to function templates, but alongside this, even whole classes can use templates. As I explained before, template means a generic data type. So we make the class template similar to the function template, write template inside the angle brackets type class, and use one capital letter instead of a word, as is typically used in programming. After making a generic data type, we can begin making our class. So make the class and name it chicken, and this will have two variables, but we don't yet know whether they'll be doubles or ints, etc. So just give it a generic data type t. One will be named first and the other second. Then we'll put some functions inside chicken. They'll both be public, and we'll make our constructor chicken. In the constructor, two numbers, set first and second, equal to the numbers we pass in. We don't know the type of numbers yet. So TA and TB. So set first equal to A and second equal to B. These two numbers in chicken will have a value. This will happen when we first build a chicken object. Then we add another method like tBigger. This will basically find out which number is bigger. We'll keep the constructor definition here and build the bigger function outside, because there are some different rules to it whenever you build a function member outside the declaration template. So we're building a function called bigger, which belongs to the chicken class outside the class. Although we made a generic type of data, whenever you have a function member outside the declaration of the class, you always need to have the function definition. So copy and paste this. Before every single function, you need to have that. To start building your function members outside the declaration of the class, first write your return type, which is t, and then write the name of the class you're going to work with. In this case, we're working with chicken class and building a function called bigger. But we can't type the function body. After the class name, add the angle brackets and add the t. Basically, we have to tell C++ that the functions template parameter is the same one they were using for the class. So that's why it's necessary to specify the t inside angle brackets after the class name. So the function called bigger will take the two numbers in the chicken class, first and second, and will find which is bigger. So return and then type if first is bigger than second, then return first, else return second. So we have a class called chicken which has two variables in it. And when we make a chicken object, give the first and second variables their values. First can be 10 and second can be 20. Then there's another function to find out which number is bigger. When we call the bigger function, it'll take the first number and the second number, 10 and 20. If 10 is bigger, it'll return 10. If 20 is bigger, it'll return 20. So let's run the chicken object and see how it works. Although there is one more thing which needs to be done. So make your chicken object, and as this is a constructor that takes two parameters, first and second, it needs two numbers like 69 and 105. Then cout c0.bigger, but bigger doesn't take those two numbers as parameters. The class has two variables in it already, so it will take those. So we'll build and run it, but we get an error message. A reason this happens is when we're working with a class template, we need to tell it what type of data we want to replace t with. And we're working with integers 69 and 105. So between your class name and object, you need to pass in int and angle brackets. This is the kind of thing people tend to forget. So when we do this, we mean this is what we're substituting for t. So if this was double, wherever the class saw t, it'd replace it with double. For example, the constructor would be passing in two doubles. When we run the function, it'll be a double, etc. When we're working with integers, we tell the class wherever there's a t, replace it with an integer. This enables us to work with different types of objects, and we can make one class an integer, one class a double, etc. When we run the program, it runs smoothly and shows 105 as the bigger number. So every single function you build needs to be preceded with a function template. You also need to have the generic data type after the class name. This tells your function that you're working with the class's template parameter. The final thing to remember is whenever you make your objects, you need to tell your object what type of data to substitute for t. That's done between your class and object declaration. So basically, if you want to build a program that takes less code and makes things a little easier, then you have the option of doing this, but it's not essential. So don't worry if it's confusing, it won't affect how and what else you learn in C++. So that's it for today. Thanks again, and bye for now.